Good evening, everyone. We are from Group 9. We'll present one of the subtopic of ENG3134 instrument and measurement called Hay Bridge. Let us uh, let us introduce ourselves first. My name is Ashaukani Nur Iman bin Muhammad Nazari. My metric number is 210885.
My name is Harunisa Umairah binti Ahmad Azwan with metric number 210028.
Okay, my name is Muhammad Rifki bin Mohamin with the metric number with 211982.
My name is Chan Zinvi with the metric number 212845.
My name is Nur Izwani binti Baharudin and my metric number is 213203.
For the introduction of Hay Bridge, first it is an improvement from Maxwell Bridge, and it used for measuring high quality factors, and it is a series connection between a capacitor and resistance.
Okay, I will explain about the definition of Hay Bridge. Okay, Hay Bridge is a electrical circuit used to measure self-inductance. It's an alternating current, AC current, that's similar to Maxwell Bridge, but with a few modification. Okay, then Hay Bridge also has the same function, which is to measure unknown inductance and resistance. Hay Bridge also called as opposite angle bridge. Okay, let me explain a little bit about the difference. Okay, the main difference between Hay Bridge and Maxwell Bridge is that Hay Bridge, the resistor and capacitor are connected in series combination. So in this case, the voltage drop across the resistance and capacitor will be changed. But in Maxwell Bridge, the resistor is in parallel with standard capacitor. So the magnitude of the voltage supply through the resistor and capacitor will be the same. Okay, after that, the Hay Bridge is more convenient for measuring inductance and resistance of coils with high Q value. Okay, that's all.
Next, for the advantages and the disadvantages of Hay Bridge. First, let me go through for the advantages first. For the first point, it is suitable for coils with quality factors greater than 10 ohms. The second one is quality factor can be expressed as a simple equation, and the last of the advantages is small values of resistance are used when determining the Q factor. For the disadvantages, there's only one that I find that are found. It is not suitable for measurement of coil with the quality factor which is less than 10.
Next, I will be sharing on how it works. As you can see from the figure, his bridge has four arms consisting of four impedances named Z1, Z2, Z3, and Z4, one in each arm. One of the impedances is unknown, meanwhile, the others are the known impedances. Impedances are the combination of the resistor inductance and capacitances. As you can see from the figure, there is a capacitance and inductance. The balance equation for the His bridge is Z1, Z4 equal to Z2, Z3. And from this figure, we can actually assume that R1 and R3 are the known value resistance. R2 and C1 have the known adjustable values. Both R4 and L1 are resistance and inductor with unknown values. This unknown L1 is compared with the standard capacitor C1. That is why it is placed across the unknown values, so it can be easy to be compared. The unknown inductance is then measured by balancing the four loads of its four arms. Balancing the circuit means adjusting R2 and C1 until the current through the ammeter or galvanometer between points A and B becomes zero. This happens when the voltage at points A and B are equal. And here is the formula according to his bridge theory that we must obey to obtain the unknown values. Let's assume that L1 is the unknown inductors having a resistance R4, R1, R2, R3 are the known non-inductive resistance. C1 is the standard capacitor for the comparison, and at balance conditions, as it says before just now, Z1 over Z3 is equal to Z2 over Z4. That's why there's the equation that looks like Z1 Z4 equal to Z2 Z3, and these are the rest of the equations. Next. And to make our life easier to count everything, there is a formula. By separating the real and imaginary terms, we will obtain this formula. Thus, the equations for L1 and R4 for the Hebrew when it's balanced are as shown in the slide. Thank you. Next.
Next, I will represent the real-life application of Heybridge. Heybridge is used to measure the self-inductance of the circuit. Second, Heybridge used to overcome the drawback of Maxwell bridge. And the last, Heybridge also used to measure the height quality factor in the circuit. The quality factor can be measured by using Maxwell as well as Heybridge, but Maxwell is used to calculate medium quality factor, which is Q is less than 10, while Heybridge is used to calculate high quality factor, which is Q is more than 10. So, to overcome Maxwell's limitation, the bridge circuit is used.
So Hayes bridge is one of the AC bridge and it can be used to measure unknown inductance and by balancing the loads of its four arms. And we can use the Hayes bridge in our daily life because it brings us a lot of benefits. And however, one of the disadvantages of the Hayes bridge is it is not suitable for measuring the coil which is less than 10 ohms of quality factor. In short, Hayes bridge is a simple circuit bridge and we can use it in our daily life, and we hope that the Hayes bridge will be used in more applications to bring convenience to us. That's all from our group, and thank you for your watching.